Hello, welcome to Helm Your Way with Kubernetes session. Hello, so I'm Ana. I'm a custom application development enthusiast and a fearless helper on subjects involving Java frameworks and IBM Cloud. Also, I'm the co-founder of Bucharest Software Craftsmanship Community, which is a community for Romanian developers founded together with Victor Renta. Nowadays, we share expertise there in Romanian, so in our native language. Maybe later on we're going to try some sessions in English. And the scope of that community is to help our local developers grow their skills, their methodologies, and all the other knowledge they could gather from all of us, actually, because we're quite a large community. I think we're around 500 right now. And a lot of us share the best practices that we have gained throughout the years. In today's presentation, I'm going to share with you how to use Helm in order to address some Kubernetes challenges, and of course, how can Helm help you into dealing with issues with, not with issues, but with Kubernetes objects and their complexity. So, what are those Kubernetes challenges? These Kubernetes challenges are actually the ones that I have identified personally when working with Kubernetes. So one of them is about managing and updating multiple configurations in Kubernetes. So if you have a complex application or platform, your configurations grow, and you end up creating a lot of configuration files, also known as manifest files and .yaml files in Kubernetes. So a lot of those are very, very difficult to be managed and to be tackled. Secondly, there is a problem in deploying those many configs as a single application. Taken, for example, a microservice application. It needs a Kubernetes deployment object, so you would know what are you deploying in terms of application. You need a service object in order to gain information, or to gain access to what you have deployed. You might need also a secret to get some connection to another service or to an external service. You can also have some config maps, and all these added give a lot of complexity to what you're deploying there. And one solution found throughout the time was to make a very, very big YAML file in which you're scrolling a lot. So you're doing that only for a single application. And if you have multiple applications, you end up with very long YAML files in which you're scrolling, and it's not that pleasant. So, and by the way, from my own experience, when scrolling in a file, I tend to forget what I was looking for in that file, and you get lost. So that's another thing that's not so nice about when working with many Kubernetes manifests. And thirdly, there's a problem with actually using parameters when you're trying to deploy in multiple environments. So a solution for the parameters part, you just copy-paste those YAML files per environment need. But that's not a very clean solution, and it's not very neat. Also, when you are doing deployments in various environments, you need a way to validate what you have done over there. So one way to validate is actually by going through each of the objects that you have deployed and see what went wrong, what went well, and so on. While as with Helm, things changed. So Helm is coming to the rescue to help us synthesize all the complexity that is in Kubernetes with our Kubernetes objects, and actually offer us a way to pattern those and to template those. What is Helm? Well, Helm is Kubernetes package manager, and is comprised of two parts. The Helm client, which can be installed in our local machine, and is the one responsible for managing the Helm charts, and of course the Helm tiller. The Helm tiller is either installed in your local Kubernetes cluster in Minikube or in your Kubernetes cluster in the cloud. And the tiller is the one responsible for the deployment and for interfacing with the Kubernetes API server. It's actually the one who's questioning about if your release was successful or not, and knowing about the state of what you have done there. Another good thing about Helm is the fact that when you're creating your own charts, you have the ability to create your own bundle of Kubernetes manifest files that are related all together. So the deployment, the secret, the service, they're all related to each other. They describe the same application that you're trying to deploy over there. So you have like one-stop shop where you see everything that is related to your app. And another neat thing about Helm is the fact that it has community charts. So for open source products that are already on the market, there are stable charts that you can install, and so there's no more work needed for those. And this is pretty cool. So Helm is good for reusability. You can reuse the same set of charts and deploy multiple times. And you can deploy multiple times by using different values. So all you change in that, you use the same templates, but you change the values.yaml content for your environment need. And this is how you can spawn multiple deployments, and the problem with parameterization that exists before goes away. Last but not least, you have a way to identify how well your release went. So when you are installing a Helm chart, the Helm release is actually providing you information related to that release, to all that happened in that release. So there's only one stop that you need to look at. You are just questioning Helm status for that release, and you get information of what went well for that one. So you can isolate very well what happened over there, and you can validate your deployment better. Let's see our playground overview for tonight. So tonight we're going to look at the frequently asked question application, which is a Spring Boot application. That's going to be deployed using Helm, of course. This application stores its data in a PostgreSQL database, also deployed with Helm. So for this one, we're going to use those community charts. The Docker image for the frequently asked question application is stored in the container registry. And to check how Helm is behaving when talking to managed services, we're going to use an IBM log analysis service in the IBM cloud. So this is our today playground, and we're going to try some approaches of deploying this. When working with Helm, there are several approaches. So the first approach is chart per service approach. The chart per service approach is actually chart per microservice approach. So you create a chart per your microservice. So you have multiple microservices, each of those has their own chart. And let's go and work a bit on this one. Cool. So I'm already connected to my Kubernetes cluster. And because we need to persist our data on a PostgreSQL database, and we're going to create a chart per service approach, we're going to install the community chart for PostgreSQL from the stable part. So the command helm install is actually taken, and all the other parameters are taken from the PostgreSQL stable chart Git repo. So there's nothing special about that one. The only difference in that one is the fact that I have just overwritten the username, the password, and the database that I'm creating over there. And of course, I'm adding the namespace where I want to use it. So let me just put this more to the center. Okay, copy pasting it. Oh wait, I don't have internet. I forgot. I started my my hotspot, but I forgot to connect to it. That's fine. Come on. Sorry for this. Come on. Should be connected to the internet. It's going to take a bit, maybe. Hotspotting. Come on. Okay. Let's just check what happened. So you see here multiple information about what was installed, what was deployed. So the resources deployed are actually standard resources for deploying the PostgreSQL database. Let's check the status of our deployment. So Helm status DB. This was the name of the release that we have done, DB. Okay. And it's up and running. So we have an up and running database, all with just one command. Now, let's go and create our own charts. Now that it's more work involved. So for our own charts, we can use the command helm create frequently asked question, and it's done. I'm just going to the workspace. So here, okay, just make this bigger. We can see that some files were already generated. So we have already the chart.yaml file, the one that is describing what is this chart about. So it's about a Helm chart for the frequently asked question application. It comes with some default values, by the way. So that was the default value for the description. And also comes with default values for the deployment. Since this does not apply to our application, so what we're trying to deploy, just going to delete it and replace it with our own values. So our own values state that we're going to use a different image, of course. We're going to have a different secret to pull that image. And of course, we have a connection to PostgreSQL database that we recently installed that we need to create. And just to double check, the secret name for the PostgreSQL database, I'm using the secret that the Postgres installation has generated, and it contains the PostgreSQL password. So I'm not storing my PostgreSQL password in the application that I am creating and I am deploying. I'm just getting it from the database installation itself. So let's just check a little bit on what was installed in terms of secret. Yeah, it's DB PostgreSQL. Okay. So, okay. And of course, the server is going to be called the same, like, I think DB PostgreSQL. So these are the details that I need for my connection. So when I'm going to install the charts for this application, I will connect to the database that I've specified here. And let's look a little bit in the templates part. Into the templates part, we have helpers.tpl. And in helpers.tpl, you can define your own template, so your own variables to play later on in the other templates. And I'm going to show you a little bit later on how you can do that. You have some already predefined, like the full name of the application or the chart name. So these are widely used into the already defined templates. And let's look into the deployment. Of course, there's something generated, but we're going to use our own deployment file. So the deployment part, let me do this and do this. So the deployment file contains all the information that you would need to fulfill most of the time in a manifest.yaml to deploy your application. So information about the repository where you're pulling your image, the tag for that image, the secret used to pull that image, and all of that is configured there. The difference between the normal manifest that you're using in Kubernetes and this one is that you're just referencing these ones using the Go template language. So it's much more easier to use these and reuse and change just the values. So we have here the image pull secrets that's corresponding to the pull secret from the values.yaml. There's also some specifications about the environment variables. And you can see here that I'm specifying the Postgres server that I'm going to use later on. So the Postgres server is the one from here, PostgreSQL.server. Also, I have this one, or a default value, in case that this one is not specified here. There is also a default that I can go to, which is also a very good practice. So when using Helm charts and Helm templates, try to specify a default value if there is possibility to that, so that you can avoid making mistakes. Second thing is about the username. So default username is Postgres, but also it can be defined at the level here. You see it's missing, but there's no problem. I have a default name, so it can go through that one. And of course, the Postgres password is taken from the secret referenced in the values, the DB-PostgreSQL secret. And all I'm referencing is the secret key, which is the PostgreSQL password. And those being said, it's pretty easy to manipulate separately the application, frequently asked application chart from the installation of the database. It's very clean, and you don't depend on anything. Next one to be tackled on is how we create a secret template. So In here, in the deployment.yaml, I'm referencing in the annotation to include also a template for secrets, so the secret.yaml template, which was, of course, not generated by the Helm create chart command. So what I'm going to do at the template level, I'm going to create my own file, secret.yaml, and, of course, populate it with my own information. So the secret.yaml file, its template is containing information about what secret I want to deploy. And it's actually the connection that I'm going to have with the logDNA managed service. So what I'm doing here is actually looking first if the values.logDNA agent key is being defined. So another good practice with Helm is that if you're unsure that a key will exist in a values.yaml, add the control statements of if, else, and so on. So there's also if, else, and some other control statements like with and include that you can use to manage your values. So here, for example, if I would leave this uncommented, this part of the chart will not be executed because the values.logDNA.agent key would not be seen, would not be present in the values.yaml file. So I'm going to uncomment it so that it can be executed also. Okay, and just have a small problem here. And of course, for the data, there is going to be the logDNA agent key, the one referenced here, and of course encrypted, in order to create my secret for that one. And last but not least, the service.yaml, the one that we are using to access what we are deploying. And let's deploy it. So this one, it gets all the data like the other one, so the header part is the same in all the charts. The only thing that changes is the ports part. So the ports part is defined by us, starting from type. We are specifying the port, the node port, and the type of the service that we're going to use to access. So I'm going to use a node port type of service. And of course, the selector, the template for selecting the app that the service should target, is the one that's the same from the one from the deployment template. And I think we're kind of done, and we can deploy our frequently asked question application. So for deploying it, we're going to issue the command helm install and provide a name for our release. If you're not providing a name for the release, there's going to be some funny name auto-generated by Helm, which is funny, but not sure in a professional environment how funny you want to be. Helm, okay. Minus name, sorry. Simple, FAQ, in the namespace dev. It's going to take a while. Huh? Sorry. I think I've made a small mistake. Service invalid value. Which one is invalid from my point of view? Spec.ports service. Come on. Work again. I'm just going to delete the previous release. One second. Oh, I forgot to save the service.yaml. Hopefully this is the problem. Yeah, forgot to save. Had some emotions earlier, but yeah. Okay, let's check the status just for making sure that it's done. Oh. Oh, sorry, simple. Thanks. I'm used all the time with frequently asked questions like, okay, let's check it. It's running, and the port to access it is 31295. 31295. Okay. Yep, it's deployed and it's up and running and working. After seeing how deployment with this templates will work, there are also some questions about how you create a template for other types of objects. So, for example, for a config map. For a config map, a template would look like similar to the one for the secret, like config map.yaml, and just quickly create it. Okay, and the value that it's going to use, I'm going to store here a small script from the values file. So in the values file, you can also reference scripts and you can put some scripts to help you into debugging. So this one is echo hello world value here will be stored in the config map, and I can run it from another job later. So what we're going to do, we're going to create this config map at the upgrade of the release. And because I said that you can use multiple values.yaml files, what I'm going to I'm going to copy this one from the FAQ and just rename it, not values.to, values.dev.yaml, and upgrade my current installation. So I'm going to say Helm upgrade the release simple using the content of FAQ, but using the values from dev.yaml. So namespace dev. Cool. And let's check the Helm history. So using Helm history command, you can check if your current release is the one that's currently, the last release is the one deployed and the other one was superseded. So Helm history, simple. So you can see here the first release was superseded, and the one running now is the release number 2. There are some disadvantages with the chart per service approach. When you have multiple microservices, like above 7, I would say, that's a good limit. The chart per service approach will confuse you in how many charts you need to manage. So it can become a little bit overwhelming because you're transforming the complexity that was at the manifest level in Kubernetes to the chart level. So you're not getting rid of everything only by using this approach. And so this is why there's another approach in dealing with Helm, the master chart approach, so also called the one chart to rule them all. And this kind of approach, you have a set of charts that you're deploying all at once. And you can do that by using the requirements.yaml file. So in the chart folder that I have here, just close all these, there is a file called requirements.yaml. And here, I specify as dependencies what I want to deploy. So my database and also my application. I want to deploy them all at once. Because I am doing this all at once, this means that I will not issue the command that I issued before, the Helm install separately for the PostgreSQL database. So what was specified in this one here, this part here with Helm install, name db, set, blah, 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 is now here at dependency level, and its values from here will be transferred at a global level in the values.yaml that is for all these charts. So when you need to install all at once, you can specify globally what can be overwritten in the big values.yaml that is controlling all the charts that you're having with your deployment. So here I've overwritten the PostgreSQL database name, the Postgres user, the Postgres password, and all the other details that I had before in the Helm install command, because I will do the installation all at once. Next, let's look at the frequently asked questions chart. In the values here, we're not going to look for the server or the secret anymore. This is because we are installing all at once, and we are taking them from the current release without making any change, so we don't need to reference and give some additional information for all at once installation, which is pretty cool. And let's go a little bit and install this one. So what we're going to do is going to install the release master using the content of chart in the namespace dev. And you'll see that a lot more information will be generated with this one. So the release part for the master is going to contain information about 2 application releases, one for PostgreSQL and one for the frequently asked questions application. So you'll see a lot more about the validated deployment part. So we can see here that upon installation, the config map was done, the pods were created for PostgreSQL and for the application, also the secrets that are needed, and so on. So it's all in one deployment, which is pretty cool. Yet, if you need to, manage a specific part of this all-in-one deployment, is not that useful all the time. So this is why there is a third approach, the so-called hybrid approach. When there are a lot of microservices, one idea would be to group those microservices and to use one master chart per service group. So you're going to have, like we have done in the second demo, the requirements.yaml per that service group, and you're going to manage only that group of services or microservices using the requirements.yaml. The advantage is that you will have a file where you're specifying the dependencies for that deployment, and you can tackle more punctually every group. So it's going to be much more easier to handle instead of having a very long requirements.yaml and deploy it all at once. You can do that too, but if there are a lot, it's better to have multiple requirements.yaml oriented on the service group. Some extra care is required when using job and crop job object templates. The reason being is that, well, you can make templates for everything in Helm, even for job and cron job. Yet these are very, very important objects, because if you do not mention the backoff limit or the active deadline seconds, you can end up with jobs that create pods indefinitely. So, and those pods are created indefinitely when the job actually is failing. So if something is failing, you will end up with in less than 5 minutes with 20 pods created, and will be retried every minute. So it's not that nice. So in case of the job and the cron job object templates, there is in between practice, like you can choose to hard code the values if you want to make sure that no colleague is going to overwrite them from the values.yaml, and you end up with a backoff limit that's higher than 10, for example. Or you can end up with active deadline seconds much higher, and you cannot stop the job anymore. Or you can define them also in the values.yaml, but be careful on what values you configure there. Also, extra care required when using secrets. Besides the all-known do not hard-code things in secrets and secret templates, actually, make sure that if something changes related to the values of your secret, even if, so for example, if your deployment values have not changed, your deployment will not be re-triggered. So your deployment object will not be re-triggered to take again the information from the secret. But if your values regarding secret have changed, those values should be acknowledged by the deployment object. So this is why it's a good thing to mention the annotation checksum config, so you can always check that if something changed with the secret, you can retrigger the deployment and redeploy and use the correct secret information. Also, there is a good use case for the helpers.tpl file for the role-based access control resources. So in this case, if you want to create the service account name and you want to manage it throughout the templates, you can do that by naming it in the helpers.tpl like I've done here, and reuse it throughout the other templates, and you can be more strict with what can be created at what level, using role-based access control resources defined in helpers and reused across the other templates. Some takeaways from the current presentation. Well, in a template, check for nested values at every level. I haven't done that in all the templates here because it would have become too complex, actually. But the if that I've done over there, it's a very good practice to check for things that you think that might not be defined, or you're not sure that will be defined in the values.yaml, or things that you're not sure you're going to obtain from the environment. Secondly, do not hard code values in templates, and especially in those templates that manage secrets, because you'll end up thinking, why has this thing been deployed with this name when I have done something else? I've specified something else in my values.yaml. Thirdly, manage your environments through multiple value files, like I've done there, values.dev.yaml, values.qa.yaml, and so on, and deploy it with that. Don't change the templates, just change the values.yaml part. And of course, mind the way you organize your charts by choosing one of the approaches, one chart per service, one chart to rule them all, or the hybrid approach if you have a lot of microservices and you would just want to isolate in groups what you are deploying. Thank you very much for listening to me. Hope that you found this information useful, and I'm waiting for questions from you. And of course, do not forget to rate me. I appreciate feedback.